Okay, this is worksheet number 1 from your review packet, and we're going to go through these pretty quickly. All right, I'm finding the limit as x approaches 2 from the left, so I would need to come in from the left-hand side until I get to x equals 2, and that's going to be 3. The limit as x approaches 2 from the right, so I'm coming in from the right-hand side, that's going to be 1. And now they're asking for the total limit, so remember the total limit, my 2, if I had my fingers up there, my 2 fingers would have to meet. They don't meet, so it does not exist. So basically, if these two numbers are not the same, then the total limit is not going to exist. D, I'm finding the limit as x approaches 0 from the left, so that's going to approach 2. Because here's 0, this way is 2. From the right, now from the right, even though I start off from the right here, I'm not to 0 yet. So I need to pick up to my other graph and keep on going until I get to x equals 0. That's going to be 2. And the total limit would be 2. Okay, number 2, the limit as x approaches 2 from the left. So I'm going to come in from the left-hand side. I'm going to follow my graph. Okay, it doesn't matter that there's this point down here. I'm going to stay with my graph. Where is my graph approaching? It is approaching 1, 2, 3, 4. From the right-hand side, as x approaches 2, I stay on my graph until I get to x equals 2. What is my y value approaching? 4. And so the total limit is 4. And I'm going to do 0 from the left. As x approaches 0 from the left, it's 1. From the right, I keep on going. It's 1. So the total limit is 1. Okay. Number 3. First one, as x approaches 2. So I'm going to go follow the limit as x approaches 2 from the left. That's going to be 1. Even though I have this open circle here, it doesn't matter. The limit as x approaches 2 from the right, same thing. I'm going to stay with my graph. It's 1. So the total limit as x approaches 2 is 1. Now I'm going to find the limit as x approaches 0 from the left. As I approach from the left-hand side, here's x equals 0. My y value is 3. And it doesn't matter that they didn't put a point there. It's still approaching that number. The limit as x approaches 0 from the right-hand side, it's approaching 3. So my total limit is 3. Okay, on this one, I'm going to find the limit as x approaches 2 from the left-hand side. From the left-hand side, it's approaching 1. Find the limit as x approaches 2 from the right-hand side. From the right-hand side, you see that's approaching 2. So the total limit, those two numbers do not match, so it does not exist. Okay, so let's find the limit as x approaches 0. As x approaches 0 from the left, it's negative 1. As x approaches 0 from the right, I'm going to pick up the graph. It stops, but I'm not to where I need to be, x equals 0 yet. So I'm going to pick up the other graph. It's approaching negative 1. So the total limit is negative 1. Number 5, the limit as x approaches negative 2 from the left. From the left, it's negative 1. It doesn't matter that it's an open circle there. From the right, the limit as x approaches 2 from the right, it's negative 1. And so my total limit is negative 1. I'm going to find the limit as x approaches 0 from the left. I can't approach this from the left, so we're going to say does not exist. Now I can find the limit as x approaches 0 from the right. It looks like it's approaching 1. And so my total limit, we're going to put does not exist. On A, the limit as x approaches 2 from the left. From the left, it's getting closer to 0, it looks like. From the right, as x approaches 2 from the right, I can't approach it from the right, so I'm going to put does not exist. And so the total limit would not exist. As x approaches 0 from the left, it's going to be 1. As x approaches 0 from the right, it's going to be 1. And then my total limit would be 1. Number 7, the limit as x approaches 2. So I have to check coming in from both sides. So as I'm coming in from the left, I'm approaching 0. From the right, I'm approaching 0. Those two places meet up. So my answer is 0. Doesn't matter that it's an open circle there. I'm going to find the limit as x approaches 0, so I have to check both sides. Here I'm getting closer to 0. It's negative 2. From the right-hand side, it's negative 2. Those places match up. So it's negative 2. And now I'm going to find f of 2. So this is saying when x is 2, what is my y value? So here's x equals 2. I have no y value because of that open circle. So f of 2 does not exist. On 8, the limit as x approaches 1, I have to check coming in from both sides. From both sides, you see that we're approaching 1, even though there's an open circle there. It doesn't matter. The limit as x approaches 0, so coming in from the left, coming in from the right, they're both approaching 2. On number 9, the limit as x approaches 1 from the left, so from the left, I'm approaching this number right here, which is 2. From the right, as I approach 1, from the right-hand side, that's going to be 1. So the total limit, okay, since the 2 from the left and from the right do not match, it does not exist. Find f of 1. So they want to know when x is 1, what is my actual y value? My y value is 1. All right, number 10. True or false? The limit as x approaches 2 equals negative 1. So as x approaches 2, here's x is 2. So from the left, I can follow this, then pick this up. It's approaching 1. From the right, it's approaching 1. So my answer is 1. They have negative 1, so that is false. Negative 1, whoops, is f of 2. So when x is 2, my y value is negative 1. Okay? The limit as x approaches negative 1 from the right. So as I approach negative 1 from the right-hand side, so I pick it up here, pick it up here, pick it up here, I'm finally to negative 1. What is my graph approaching? It's approaching 0. So they said it's approaching 1. So that is false. The limit as x approaches 1 from the right-hand side. As x approaches 1 from the right-hand side, I'm going to come in from the right, coming from the right. Here is 1 finally. So from the right-hand side, my limit is 1. So that is true. The limit as x approaches 2 exists. So here's 2. I just have to make sure that as I'm coming in from the left and coming in from the right, they're meeting around the same point. And they are. It's 1. So that is true. The limit as x approaches 3 equals 1. So here's 3. As I approach from the left, you see I have a value of 1. As I approach from the right, I have a value of 2. So that does not exist. Oh, that's false. They said it's equal to 1. Whoops. But it's actually does not exist. So that is false. The limit as x approaches 1 does not exist. So the limit as x approaches 1. From the left is 2, from the right is 1, so that is true. The limit as x approaches 3 from the left. So from the left, when I get to 3, my graph approaches 1, so that is true. H, the limit as x approaches 0 is the same as the limit as, okay, let me say that again. The limit as x approaches 0 from the right is the same as the limit as x approaches 0 from the left. Okay, so here's 0 from the left, it's 1. From the right, it's 1, so that's true. The limit as x approaches 0 exists. Well, since these two things were equal, then that has to be true. The limit as x approaches 2 is 1. So right here as x approaches 2 from the left, it's 1. From the right, it's 1, so that is true. J, the limit as x approaches 2 is 1. So as I approach it from the left, it's 1. From the right, it's 1. That's true. The limit as x approaches c exists at every c on the interval from 0 to 1. So here's what they're saying. From 0 to 1. So from here until 1 to here. Just in between those. It doesn't include the endpoints. Okay, because it's an open interval. Those parentheses mean open intervals. Does the limit exist on this red line everywhere? Yes, it does. Okay, there's no breaks in the graph or anything like that, so the limit does exist. All right, so the next one is pretty much the same, but they've changed my interval. So let me get rid of that. Now they're talking about from 1 to 3. So from 1, so from 1 right here, here's 1, to 3, not including the endpoints. Okay, so not including the endpoints. So I can't include this point, can't include this. Does the limit exist everywhere? Yes, it does. Even though there's an open circle here, the limit still is approaching the same number. So that is also true. Okay, and that is worksheet number 1.